So today we're going to use the principle of moments to help us find unknown forces or unknown distances. So last week when we did our experiment, we confirmed the principle of moments and we said when the system was balanced, and that was really important, the total clockwise moments equals the total anti-clockwise moments about the same point, which is our pivot. So if we use this information and a question tells us that the system is balanced or in equilibrium, so let's write down some keywords. So balanced, equilibrium, and whenever a system is balanced or in equilibrium, then it's not moving. All of these keywords tell us that the anti-clockwise moment, which I'll write like that, is equal to the clockwise moment. And just a little reminder that when we were learning about calculating moments, a moment is equal to the force times the distance. So let's look at some examples here. Here I have two systems, and the question says, are these systems in equilibrium? Well, if they're in equilibrium, the anti-clockwise moment must be equal to the clockwise moment. So I need to figure out what the anti-clockwise moment is and what the clockwise moment is, and figure out if they're the same. And if they are, then the system's in equilibrium. So first of all, my anti-clockwise moment. So let's think about this. I put my pen on my page and I hold it at the pivot and I push in this direction. And I find that my system will rotate about that pivot in that direction. So that 6 newtons is my anti-clockwise moment. And then I do the same on the other side, and I find that that 2 Newton force causes my system to rotate in a clockwise direction. So that force is going to cause my clockwise moment. So let's go first to the anti-clockwise moment. Moment equals force times distance, and my force is 6. My distance from the pivot has been given to me is 1 meter, so therefore my moment is 6 Newton meters. My clockwise moment equals force times distance. The force causing my clockwise moment is 2. Its distance from the pivot is 3 meters. So therefore that moment is 6 Newton meters. So in this case, the anti-clockwise moment equals the clockwise moment. So therefore it is in equilibrium. Okay, you have a go at this question here. Okay, question 2. Find the value of the missing force so that the seesaw balances. So once again, when the system is balanced, the anti-clockwise moment must be equal to the clockwise moment. And if I write that down, I have 1 mark. Now I'm going to have a look at my diagram and see what direction these forces are acting in. So I hold my pen at this point, at the pivot point, and I push it down. And I realise that that force is going to cause an anti-clockwise moment. And if I do the same on this side with the downwards force, this force is going to cause a clockwise moment. So if this thing is balanced, the anti-clockwise moment equals the clockwise moment. So let's calculate the anti-clockwise moment. Well, the force, let's call it F. I don't know what that is, so I'm just going to leave it as F. And its distance from the pivot is 16 meters. On the other side, I have my clockwise moment. Its force, because remember, moment equals force times distance. This is where this is coming from. That force is 8 newtons, causing the clockwise moment, and its distance from the pivot is 4 meters. So I have a sum with only one unknown. So let's do some maths and figure out what this value for F is. So 16 times F gives me 16F, and 8 times 4 is 32. But I don't want to know what 16f is equal to. I want to know what 1f is. So to find what 1f is, I have to do the opposite of multiplying by 16. So I divide by 16 on that side, which means I have to do exactly the same to the other side, and I divide by 16. So 32 divided by 16 gives me 2, and force is measured in newtons. So therefore, I have my answer. So the force is equal to 2 newtons. Okay, so your second part of your homework is to complete question 3 and find that unknown distance. So the first thing you need to do, step 1, identify the clockwise and anti-clockwise moment, just the same way I did before. Then you write down that your anti-clockwise moment equals your clockwise moment. And then you simply do force times distance. Force 1 times distance 1 is equal to your second force times its distance from the pivot. And then you find your unknown. And just follow the method for the previous question to help you through it. If you get stuck, email me and I'll give you a little video help. Thank you.